to the chemistry channel, and today we're going to be talking about the last method used to determine the heat of a reaction. So this method uses the heat of formation for a particular compound. So what is the heat of formation, or enthalpy of formation? Well, the heat of formation is first of all given this symbol, and the heat of formation is the change in enthalpy associated with the formation of a compound from its constituent elements. So it's the change in enthalpy associated with the formation of a compound from its constituent elements. Now, the enthalpy, the value of the enthalpy of formation for a particular compound can vary. So in other words, one compound can have multiple heats of formation values. And the heats of formation, the heat of formation value for a compound can vary depending upon three factors. And these three factors are the state of the compound, so in other words, whether it is a solid, liquid, or gas. So in other words, the heat of formation for water can vary depending on whether it's in solid, liquid, or gas form. The second is the pressure exerted upon the compound, and the third is the temperature. Therefore, since the heat of formation value can change depending on these three factors, we need to find a certain standard set of conditions in order to compare enthalpy of formation values to each other. So we need a standard to compare the heats of formation values between different compounds and different states of the same compound. So in other words, we need a certain set of standards, so we need a certain standard conditions in order to compare heat of formation values to each other. So we need to have a standard conditions in order to compare heat of formation values between different compounds. And we also need a certain set of standard conditions in order to compare heat of formation values between the same compound but when it's in different states. So for example, solid water, liquid water, or water vapor. Now this standard is referred to as the standard state or standard conditions. So standard conditions. And the standard conditions that we use to compare different heats of formation to each other is 298 Kelvin and 1 atmosphere of pressure, as well as 1 molar concentrations if it's aqueous solution. So the heat of formation measured under standard conditions is referred to as the standard heat of formation, and it is given this symbol. So this is the standard heat of formation. So what is the standard heat of formation? It is the change in enthalpy associated with the formation of 1 mole, so it's important to know 1 mole of compound from its constituent elements under standard conditions. So it's only under standard conditions, so 298 Kelvin and 1 atm of pressure. Now, it's important to note that the values for the standard heat of formation can be found usually in a textbook in the back of the book, and if it's on an exam, they should give it to you as well. However, one important thing to note is that the standard heat of formation for elements in their most stable form is 0 kilojoules per mole. So the standard heat of formation for elements in their most stable state is equal to 0 kilojoules per mole. And that's because if they're in their most stable state at the standard conditions, then it is assumed that, and it is known that the elements in that form are already present and don't have to be formed. Therefore, since these elements are already present, there is no heat of formation value for the elements in their most stable form. So examples of this would be O2, H2, etc. And these will usually be given to you as well. So just quickly right here, the units for delta HF in the standard state is kilojoules per mole or joules per mole. So now that we know what the heat of formation is, how can we use it to find the heat of a reaction? So you may remember from one of my earlier videos that the heat of reaction is equal to the enthalpy of the products minus the enthalpy of the reactants. So how can we use heat of formation values in this equation here? Well, to understand how, we have to look at the units once again. Remember that the standard heat of formation has the units of kilojoules or joules, depending on what you get, per mole. So how can we just get a unit of energy out of this? Well, all we'd have to do is multiply the number of moles of a particular substance. So for example, if you had A plus B going to C, in order to get the heat of reaction from this and the different enthalpies for the products and the reactants, what you would have to do is find the standard enthalpy of formation or heat of formation for A and multiply it by the number of moles of A. You'd have to do the same for B, and C. So if you multiply the standard heat of formation by the number of moles of that particular substance, you will get a unit of energy, or kilojoules. So how can we put all of these together in order to find the heat of a reaction? Well, in order to put these together, we just follow our equation above. The heat of reaction is equal to the enthalpy of the products minus the enthalpy of the reactants. So therefore, all we have to do is arrange these different equations here into the equation above, or substitute in. So for this reaction here, the heat of reaction for this reaction here is equal to moles of C times the heat of formation for C minus moles of A times the heat of formation for A, standard heat of formation, and moles of B times the standard heat of formation for B. So that's how you find the heat of reaction for this particular reaction. Now the general equation for finding the heat of reaction using the heat of formation, the standard heat of formation values is this. So this would be the equation that you can use to find the heat of reaction using standard heats of formation. So, but recall though that we can only use the standard heat of formations when we are under standard conditions, so 298 Kelvin and 1 atm of pressure. Now, you will generally be under standard conditions for general chemistry, and when you go outside standard conditions, that is outside the scope of general chemistry. So in order to understand how to use this equation better, let's do one practice problem. So one practice problem. So let's just say we have this reaction. So we have this reaction, and I'm going to give you the standard heats of formation for each of the things. So what I want you to do is to calculate the heat of reaction for this particular reaction. And when you are done, come back and see if you got it right. So welcome back if you did this. Let's start out first by balancing the chemical equation. So let's just rewrite it here. So let's balance this. So in order to balance this, the best way to do this is to multiply the SO2 and the SO3 by 2. So 2SO2 plus O2 goes to 2SO3. And if you have trouble balancing chemical equations, please go see one of my previous videos. So let's put the states here. And now we're just going to bring in our delta H of reaction equation. Now the delta H of reaction is equal to the enthalpy of the products minus the enthalpy of the reactants. So in order to do this, we have to substitute in our heat of formation values. So we have 2 moles of the SO3 times the heat of formation for SO3 minus the 2 moles of SO2 times the standard heat of formation of SO2. And this will give us the heat of reaction. Remember that the heat of formation for O2 is 0. So when you substitute those in, so net times negative 395.2 kilojoules per mole, let's just put our units there so we could just see them cancel out. So when you go through this on your calculator or do the arithmetic, you can see that moles cancel out. And when you do this on your calculator, you should get negative 196.6 kilojoules. And that will be your delta H of reaction. So that is it for this video, and that concludes our series of videos on thermochemistry. And I hope that this video cleared up some stuff for you. And in the next video, we're going to be talking about units of concentration, so molarity, molality, all that stuff. So I hope to see you there. Thank you, and see you next time.